Over the past half-century, various malaria treatments have been developed only to have their efficacy thwarted when the malaria parasite developed resistance to them. And the parasite's defense has been abetted by the way drugs are used and the social and economic conditions that contribute to malaria transmission. I'm Stephen Morrissey, managing editor of the New England Journal of Medicine, and I'm talking with Randall Packard, a professor of the history of medicine at Johns Hopkins University. Dr. Packard has written a perspective article on the origins of antimalarial-drug resistance. Dr. Packard, malaria has a long history. Can you tell us a bit about when, where, and how it was first identified and how it was first treated?
Identified is a relative question because malaria has been around for centuries. I mean, it goes back, at least falciparum malaria probably goes back to 10,000 BC. So when it was identified in terms of bacteriology and science, it would be the end of the 19th century. And at that point, there were few treatments. Basically, there were treatments that were related to trachona bark that was discovered in the 17th century as being effective against what we now believe was malaria. And then derivatives of that, particularly quinine, which emerged in the 1920s as an effective treatment for malaria, or actually before that, for malaria. And basically, that was the way in which malaria was treated for quite some time, and certainly until World War II, that was the main drug for treatment. And it was also used for efforts to prevent malaria, the most famous case being in Italy, beginning of the 20th century, where quinine was actually used in an effort to eliminate malaria from the country. It was unsuccessful. It did drive down mortality, but it didn't have a great effect on morbidity.
You point out in your article that although antimalarial drugs have been around a long time, the emergence of antimalarial drug resistance is a relatively recent phenomenon. So do we have a sense of why the first round of that cycle took longer than these more recent rounds?
It's not clear. Resistance to quinine developed more slowly. It may have been the ways in which it was used. Quinine resistance developed or was discovered in Germany in the 1920s, but it remained fairly effective in preventing or curing or treating malaria for quite some time. You have, during the 1950s, in efforts to bring about the control of malaria widely across the globe in areas which were so-called developing countries, where malaria was viewed as a major impediment to economic growth, an effort to both prevent disease, prevent malaria, and to control it more effectively. And so you get much more widespread use of drugs, and particularly derivatives of quinine and chloroquine most particularly, which became the sort of mainline drug for preventing malaria during the 1960s and 70s, and it was used worldwide. So it has a lot to do with the scale at which drugs were in fact being used, and to the fact that there was a major push to bring malaria under control over large parts of the globe, whereas before that time, it had been used much more sparingly.
New drugs appeared after chloroquine resistance emerged, but one problem with them has been adverse effects with drugs such as sulfadoxine, pyrimethamine.
Mefloquine.
What are those side effects, and how are they different from the ones associated with chloroquine?
There's a variety of side effects. I mean, mefloquine is the one that people speak a lot about because it became the sort of, once chloroquine resistance became widespread, it became a kind of, during the 1960s and 70s, it became a sort of major drug for preventing falciparum malaria. But it has severe sort of, or can have, not everyone has this reaction, but can have fairly severe psychotic kinds of reactions. And people have hallucinations, people have headaches, people have a range of different reactions to it. And why it is that these particular sort of second-line antimalarials have more adverse effects, I'm not sure. I'm sure someone more specialized in their treatment could tell you that. But I think it's clear you're right that they have had more side effects, and they also cost more with each generation. And that has also been one of the detriments to their use.
In another advance, artemisinin was rediscovered in the 1970s. Of course, it had been used by Chinese herbalists for centuries. What had they been using it for, and what led to the rediscovery?
It occurred in the 1970s, in part because the North Vietnamese requested support from the Chinese to help them develop a way of controlling malaria, which was affecting North Vietnamese troops as well as the U.S. troops. And it became then used by the North Vietnamese during the war It doesn't seem to have been, or actually didn't really appear in the West after that for some time, and it wasn't until the 1980s and 90s that it becomes available, and then sometime after that until it becomes readily used or widely used for malaria control outside of China. How long it's been used in China, we have no idea. I mean, we have people have given dates, but clearly for centuries.
You describe in your article an effort by the World Health Organization to restrict the use of what was the first widely available artemisinin combination therapy, Coartem, and that didn't succeed because of pressure from national health programs. Given the emerging resistance, which is reported in a research article by Ashley and colleagues, do you think the WHO should have stood its ground?
It was always a difficult question. If you look at the history of efforts to control falciparum malaria and the impact that falciparum malaria has had on populations affected by it, you see that once chloroquine resistance developed and secondary drugs had their problems, that you had fairly significant spikes in mortality, particularly in sub-Saharan Africa. So the pressure to find a drug that would be effective for treatment was intense, and there are strong arguments that it should well have been made available. The problem was not so much with the way it was made available, but the fact that it's the way it got used once it was subsequently made available, once the WHO said, okay, they can be used for a first-line drug. Then you have all sorts of problems of the kinds that I talk about in the article, but particularly the development of the use of monotherapies with artemisinin. It was not prescribed. It was not what the WHO was advocating and promoting, but nonetheless, for financial reasons, companies, and of which there are a lot of small producers of this drug, particularly in China, that were marketing monotherapies, and monotherapies were cheaper, and there's an economic incentive for people who are trying to get drugs who don't have many resources, resource-poor areas, to find the cheapest therapy possible. So there were a lot of kind of forces that were working against the prescription of the use of artemisinin combinations, and I think that, plus the widespread emergence of counterfeit drugs and the ways in which it was being distributed, I think undermined the good intentions that were put forth by the WHO. So I guess the answer is that I think ultimately it was necessary to make it available. Unfortunately, once you did so, it was very difficult, or it proved very difficult, to insist that it be used in a proper way in a combination with other therapeutics, which would at least restrict or limit the speed with which resistance emerged.
You describe in the article the social and economic conditions under which chloroquine resistance first emerged in an area of Cambodia where migrants were working in gem mines that created mosquito breeding sites. What can malaria control programs do about problems like that?
I think it's difficult for malaria control programs per se to deal with those issues. The question is, can you effectively control malaria in any place where you have social and economic conditions which are in fact working against those efforts? So in other words, can you simply ignore those issues and simply go ahead distributing drugs? And what I suspect is the case is that, or the answer is that it can work in some places, but in many places it can't work, and that there needs to be more coordination with other forms of social and economic development. It's not that the malaria control programs are responsible for changing the world, but there needs to be a sensitivity to the need for more interaction, coordination amongst various development agencies, various elements of government. When rollback malaria began back in the 1990s, this was part of the prescription, or this is part of the design, that there would be multiple agencies, multiple international organizations working with agriculture, with economic development, who would all be working toward improving conditions and improving health. As it turned out, that kind of integration never really occurred. And so you have a situation in which you're trying to control malaria with basically fairly narrow biomedical approaches, which can be effective, but where there, as I said, where there are forces which are working against it, where you have migration patterns that allow people who are infected to move from one area to the next, and a variety of different conditions which undermine control, then it's difficult to actually sustain control and to prevent the emergence of resistance.
You end your article with a call for new generations of antimalarial therapies. Judging from the historical cycle and our current knowledge, do you think that the global health and scientific communities will get better at preventing resistance, or will that cycle continue to speed up?
I think that, again, it's this question of integration, that it's very difficult to imagine how the scientific and biomedical community can develop programs that deal with all of these social and economic contingencies. And so the call for the continued production of new forms of antimalarials is a recognition of the reality on the ground, that it's unlikely that these conditions are going to be changed, certainly in the short-term, mid-term. Perhaps they will be in the long term. But obviously you can't wait for that to happen. So what you're going to get is repeated emergence of resistance to drugs, and you're going to have to continue developing new pipelines of drugs that can be put into play when resistance emerges. There are clearly efforts being put into effect in the Mekong Delta region, for example, and the Gates Foundation is involved in this as an effort to sort of prevent the further emergence of any resistance to artemisinin and to prevent its spread. But this is a challenge, and whether, in fact, it can occur when the social forces continue to be at play is unclear. So I think that it is better to be prepared for resistance to emerge than to hope that these control methods will, in fact, be effective and then find that they're not and that you're left without any weapons at all.
Thank you, Dr. Packard.